Hey everyone, and welcome to this explainer. If you've spent any time at all writing C code, you've probably seen those lines starting with a hashtag and just thought, well, that's just some confusing compiler magic I have to accept. But today, we are going to completely flip that script. The C preprocessor is absolutely not magic. It's actually an incredibly powerful, really manageable toolkit, and you are about to master it.
Right out of the gate, I really want you to change your mental model. Just imagine for a second, what if you had a tireless, automated assistant whose entire job was to prep and organize your workspace before you actually sat down to work? Well, that is exactly what the preprocessor is doing. It's basically an automated robot assistant formatting your C code before the compiler ever even gets a glimpse of it.
All right, Section 1, Meet Your Preprocessor Robot. Okay, let's dive right into this. Welcome to your full tutorial and reference toolkit. For the rest of this explainer, I want you to look at the C preprocessor as, well, kind of like your little brother, but as a robot. Seriously, this is going to be the overarching theme that makes all those confusing hashtag symbols instantly make sense. Let's think about how this robot actually operates. Let's say you're writing a letter to a friend. But before that letter ever gets to its destination, your little brother intercepts it. He goes through and replaces the word pi with 3.14159. Maybe he sticks a whole other letter inside of yours, crosses out some paragraphs you specifically told him to hide, or he just yells error and stops the delivery entirely. Finally, the teacher, or in our programming case, the compiler, reads this final modified letter. This is the exact three-step flow of C programming. You have your raw.c source code. The preprocessor robot intercepts it to expand your macros and include headers, and only after all that does the C compiler actually see the code. The preprocessor happens entirely before compilation even starts. Moving on to Section 2, the Core Directives Toolkit.
So, how exactly do we boss this robot around? We use specific tools called directives. You'll always spot them because they start with a hashtag. Think of them as direct commands for the robot. Like hashtag include just tells the robot to go find another file and stick its entire content right into yours. Hashtag define tells the robot to create a shortcut. It's a strict find and replace macro, like telling it to replace pi with 3.14159 everywhere in your text. And hashtag undefine, that simply deletes a previously created hashtag defined shortcut, basically telling the robot to just forget about it.
But the robot can also make decisions using slightly more advanced logic. ifdef and ifndef tell the robot to only keep certain chunks of code if a specific shortcut has or hasn't been defined. You also have standard -if, -elif, -else, and -endif for conditional compilation. Now, if things go wrong and you need to forcefully stop the process, -error makes the robot throw a compiler error with your custom message. And finally, there's pragma once, which is a really handy modern command that just prevents a header file from being included twice.
Let's actually put a massive spotlight on what is arguably the most powerful concept here, conditional compilation. By combining #define with #ifdef, you completely control what code actually exists in the final file that gets handed to the compiler. Think about this logic for a second. If we define debug, the robot leaves the print statement in the code. So if we compile our code using the flag DDEBUG, that debug code appears to the compiler. But here is the brilliant part. If we compile without that flag, the preprocessor removes those lines completely. It is literally a zero-cost operation because to the compiler, that debug code just does not exist.
Section 3, Understanding Header Management. Let's see how the robot handles our files.
When you're building massive projects, you're going to use a lot of files, and you need to bring in function prototypes so the compiler actually knows what functions exist. Writing #include main.h tells the robot to bring in those prototypes. But what happens if two entirely different files both tell the robot to include main.h? Without some kind of protection, the robot is just going to blindly paste the exact same code twice, which causes massive redefinition errors. And that is exactly where #pragma once comes in. It explicitly tells the robot, hey, don't read this exact same header file twice.
Which brings us to Section 4, Building Safe Debug Macros. Theory is great and all, but let's look at how you will actually use this in your code today to write truly professional software. We're going to do a practical build right now, broken down into 3 totally digestible steps. First, we'll construct a super clean, Betty-friendly main.h file. Second, we'll build a safe, zero-cost debug macro. And third, we'll see how to easily toggle our terminal execution flags.
And honestly, This three-step process is the exact workflow professional C developers use to keep their logic clean and their debugging environments powerful, all without sacrificing an ounce of performance in their final release builds.
All right, let's start with step 1, the clean header file. Take a look at this setup for a main.h file. Notice the structure here. Right at the very top, we have hashtag if not main.h, followed immediately by hashtag define main.h. Then we drop in our hashtag pragma once, our standard library includes, all of our function prototypes like _putchar and _islower, and finally, all the way at the bottom, an hashtag end to close the whole block out.
Now, what's really interesting here is the redundancy. You might be asking, why do we have an ifdef not block and a hash pragma once? Because, well, this is the ultimate bulletproof architecture. The ifdef not block is your traditional guard. It works flawlessly on literally every single legacy compiler out there. On the other hand, hash pragma once is the modern way to explicitly prevent double inclusion, and it actually compiles slightly faster. Using both gives you clean, redundant protection and builds a fully Betty-friendly architecture that is never going to fail you. Step 2. Building the safe debug macro. This right here is where we leverage that conditional compilation we were talking about earlier. We check hashtag ifdebug. If that's true, we define debug print to be a nice, sophisticated printf statement. But if it's false, meaning we hit the hashtag else block, we define debug print to be do empty while 0.
Let's break down the anatomy of why this is so clever. In the active debug state, we're using some serious built-in preprocessor magic, double file and double line. The robot automatically injects the exact file name and the exact line number where the macro is called. And look at that else block. The safe fallback is do while 0. I know, it looks like a glitch, right? But it's actually a brilliant hack. It forces the macro to behave like an empty block that literally just does nothing. But most importantly, it absorbs the trailing semicolon when you call the macro, meaning it won't break your standard C syntax. And remember, this macro entirely disappears from your code unless you compile with that DDEBUG flag.
Just look at how this transforms your actual C files. Inside main, there are absolutely no messy, scattered hashtag if statements cluttering up your business logic. We just have these really clean debug print calls. The robot is handling all the complex conditional logic behind the scenes, leaving your main file incredibly pristine and readable.
And finally, Section 5, Execution and Professional Mindset. Let's run this code.
So the code looks great, but how does it actually behave when we hit the terminal? This brilliantly illustrates the true power of the preprocessor. On the top, we compile with our standard flags, but we add -d debug. When we run it, boom, our console prints out debug file.c, line 5, program started. The robot left the code intact. But check out the bottom. When we compile normally without that flag, it operates at 0 cost. The robot erased those debug print lines entirely before compilation even started. It didn't just mute them, they are completely gone. Your final production executable is smaller and it runs faster.
And this all brings us to our ultimate goal, developing that true preprocessor mindset. Because by understanding this tool, you aren't just writing code that works, you are writing incredibly clean, Betty-friendly, professional C code.
So the absolutely crucial point here is to take these 4 actionable rules and carry them into your daily workflow. Number 1, always think of the preprocessor as your little brother robot organizing your code before compilation. Number 2, use hashtag define to create really reliable, predictable text replacement shortcuts. 3, professionally protect every single header file you make with both hash pragma once and your standard ifndef guards. And 4, actively leverage conditional compilation, like our hash ifdef debug macro to build powerful, zero-cost diagnostic tools.
You've completely demystified the magic. You've got the mental model, you know the syntax, and you see the practical implementation. The preprocessor isn't an obstacle anymore, it's literally your ultimate assistant.